Unit Operation Classroom. We are now discussing GATE 2023 question 14. For a two-dimensional plane, the unit vectors of the polar coordinate system. So these are the unit vectors in the polar coordinate system. This is going radially upward, and this is, of course, tangential to the radial vector. And the Cartesian coordinates unit vector. So this is my Cartesian coordinate system. And this is, of course, my polar coordinate system here. These are angles are, of course, 90 degrees. The relationship is already given in this problem. So we have to find out this derivative. That means when this addition of the unit vectors in the polar coordinate system starts rotating, the theta changes, then what is the value? So we have to find that out. Now, if we do it just mathematically, then this is very easy. Only thing what you have to do, you take this one right here, E plus E theta, which is this, and you take the derivative with respect to theta here. So here we are taking actually here, this is the derivative with respect to this one right here. And when you take the derivative with respect to that, of course, this is what it comes, because the derivative of sine theta is, of course, cosine theta, and those cosine theta is, of course, negative of sine theta. Same thing right here. And so if you just lump them together for the if you just lump them together, then, of course, we get this E theta right here. And this is, of course, negative of ER, which is right one this year. So this is very easy. Details, of course, are shown here. And therefore, we can say this is D is the correct option. Now, what could be the application of this one in terms of chemical engineering? Let's say we have a vessel in which there's a starter, and the starter is moving. So if you want to find out the velocity vector in the polar coordinate system of the fluid just adjacent to the tip of this starter, so we can take the position vector, of course, as this one. This is my unit vector in the radial polar coordinate system. So if you find out the velocity, if you want to find out the velocity with respect to that, then we take the derivative with respect to time, and this is what we get. And this is, you have to do a little bit of trick here, which we have shown, and that's what it comes to E theta. So basically, this is the velocity vector of the fluid, which is at the tip of this starter. So as we can see, the velocity is, of course, you can just split it down to the radial vector direction, and, of course, the angular vector direction. So then you can do all kinds of maths with it. In fact, you can use the Navier-Stokes equation to that, and you can find out the velocity profile of the vortex of the fluids within this rotating within this vessel with the rotation of the star. So going back, if you want to see the solution of this one, then this is really very easy. That's the way you do it.